हेलो बच्चों, तो अब यूनिट डायमेंशन एंड मेजरमेंट चैप्टर हमारा कंप्लीट हो गया एंड नाउ वी आर इन अ पोजीशन टू असेस हाउ मच वी हैव लर्न टिल नाउ। तो हम लोग स्टार्ट करते हैं विथ फ्यू ऑफ द क्वेश्चंस आई हैव सिलेक्टेड फॉर यू एंड लेट अस सी हाउ मच यू कैन स्कोर। शैल वी स्टार्ट? The question session starts with the first question in which the density measurement of a cube, mass and edge length are provided. This is mass given with uncertainty and this is edge length with uncertainty provided. Now it is asking for error in measurement of density. Now what is formula of density? Rho is mass upon volume, and since it is a cube, so it can be written as mass upon L cube. Now if we apply the formula for relative error, delta rho upon rho is equal to delta m upon m plus thrice delta L upon L. Now if you substitute values here, delta m is given, this is delta m 0.10 upon mass which is 10 kg plus 3 into delta L is given 0.01, so 0.01 upon 0.1. These two values will be, this is 0.01 plus 0.003. On adding, this will come as 013. This is delta rho by rho, but it is asking for error in measurement of density. So actually delta rho is desired. So this value has to be multiplied with rho, 0.013 rho. First we have to calculate value of rho. What is rho? This is mass upon L cube. If you substitute values here, 10 kg upon L cube, this is 0.1 and cube of this can be written as 10 to the power 4 kg per meter cube. Multiply this value with the value we got from calculation of delta rho by rho. It is 0.013 into 10 to the power 4, which is equal to 130 kg per meter cube. The correct option is third. This question, as you can see, had come in JEE 2090, but none of the option was correct, and this is the correct option. Now move to question number 2. Relative error in determination of surface area of a sphere alpha. Then relative error in determination of its volume is. Now what is surface area? That is 4 pi r square is equal to A, and it is given delta A upon A. So this will be equal to twice delta r by r. This value is given as alpha. Now we have to write relative error in volume. So delta V by V would be, as you know, volume is 4 by 3 pi r cube, so it has to be 3 delta r by r. Now if you substitute value of delta r by r from the above, so that would be alpha by 2, so it is 3 into alpha by 2. The correct option is 3 alpha by 2, which is the first option itself. Now let's move to question number 3. The percentage error in quantities P, Q, R and S are 0.5%. It is saying the percentage error in quantities P, Q, R and S are 0.5%, 1%, 3% and 1.5%. One physical quantity is given there, P cube Q square upon root under R into S, and it is asking for percentage error in A. So percentage error in A will be, from the given formula we can write A, this will be equal to 3 times percentage error in P plus 2 times percentage error in Q plus 1 by 2 times percentage error in R plus 1 time percentage error in S. And if you substitute the values, it will be, in P this is given 0.5, so 3 into 0.5 plus 2 into 1% plus 1 by 2 into 3 plus 1.5. These all values are given in percent. If you add up the values, this will come out as 1.5% plus 2% plus 1.5% plus 1.5%. That is equal to 6.5%. So first option is correct. Now this is question number 4. A student measured the length of a rod and wrote it as 3.50 centimeter. Which instrument did he use to measure it? Here you can see the measured length is 3.50. After decimal 2 digits are there. So it must have been measured with an instrument for which least count is 0.01 centimeter. Now so many instruments are given in different options, so we have to check in which instrument least count is having value 0.01 centimeter. Let us start with first option. This is a screw gauge having 50 division in circular scale and pitch is 1 mm. So that would be least count would be pitch upon number of division on circular scale, which is 50. This won't be equal to 0.01. So this option is not correct. Come to the next option. A meter scale. For meter scale, as we know, the minimum value that can be measured is 0.1 centimeter. So this also cannot be correct. For third, a vernier caliper where 10 divisions in vernier scale matches with 9 divisions in main scale, and main scale has 10 divisions in 1 centimeter. So here you can see that 10 division in vernier scale is coinciding with 9 division on main scale. So 1 vernier scale division would be equal to 9 by 10 MSD, and as we know, least count is 1 MSD minus 1 VSD. If you substitute the values here, that will be 1 by 10 MSD. Now what is 1 MSD? It is 10 division in 1 centimeter. So that would be 1 by 10 centimeter. This is equal to 0.01 centimeter. So third option is correct and there is no need to check for fourth option. Come to question number 5. Resistance of a given wire is obtained by measuring the current flowing in it and voltage difference applied across it. We all know the formula. This is very famous Ohm's formula, where R is written as V upon I. If percentage error in measurement of current and voltage differences are 3% each, then error in value of resistance of wire is. Now first write the famous Ohm's law. R is equal to V by I, and we can write delta R upon R is equal to delta V upon V plus delta I by I. If you substitute both the values here, that will be 3% in both, so it has to be 6%. The correct option is option number 4. As you can see, these questions may come in NEET as well. Next is question number 6. A student measured the diameter of a steel ball using a screw gauge of least count 0.001 centimeter. Least count is provided, that is equal to 0.001 centimeter. The main scale reading is 5 mm. Directly I can write MSR, which is 5 mm. And 0 of circular scale division coincides with 25 division above the reference level. So vernier scale reading would be, here it is saying that 0 is 25 division above the reference level. So what should be the vernier scale reading? This shows that 25th division is coinciding with the reference line. So 25 multiplied with least count. This will give you vernier scale reading. Now this multiply with 0.001, you will get 0.025 centimeter, and in millimeter it can be written as 0.25 mm. Now these two has to be added. So if you add these two, you will get 5.25 millimeter. After this, we have to make zero correction. What is zero correction here? Zero error is given. This is the negative value, minus 0.004, and as you all know, if zero error is negative, we have to add the zero error while doing final correction. So it has to be 5.25 plus the zero error here is given in centimeter. So first convert it to millimeter. So that will be 0.04 millimeter. Add this with 0.04. You will get final answer as 5.29 millimeter. And if written in centimeter, that is 0.529 centimeter. As you all can see, first option is correct. Move to question number 7. A physical parameter A can be determined by measuring the parameters B, C, D and E. Here the physical quantity A is depending on B, C, D and E in the given manner. If the maximum error in measurement of B, C, D and E are, these are the values provided for percentage error in B, C, D and E. Then it is asking for maximum error in value of A. Now, as the expression is B to the power alpha, C to the power beta upon D to the power gamma and E to the power delta. So if it is asking delta A upon A, of course that is given in percentage, so that will be equal to alpha times delta B by B plus beta times delta C by C plus gamma times delta D by D plus delta time delta E by E. These values are provided. These are all in percentage. The values are provided here. Delta B by B in percentage is B1%. So it is alpha B1 plus, similarly we can write all the values, beta C1 plus gamma D1 plus delta E1. This much percentage. Which option is correct? As you can see here, option number 4 is correct. Now move to question number 8. A screw gauge with a pitch of 0.5 mm. Pitch is given here, that is 0.5 mm. And number of division on circular scale is 50. So N is 50. First, with help of these two, calculate value of least count. That would be equal to 0.5 upon 50, which is 0.01 mm. So this is the least count of screw gauge provided. Now before starting, it is found that when two jaws of screw gauge are brought in contact when no object is placed, so it is showing the zero error. First write the value of zero error. What is the error? Now as I had told you, you can recall that if the value which is coinciding when no object is placed between the jaws, the value which is coinciding with reference line, if it is less than n by 2, zero error has to be subtracted, and if it is more than n by 2, zero error has to be added. Here value of n is 50. So n by 2 would be 25, and we can see 45th division is coinciding. 45 is more than 25. So here zero error has to be added. And if it is to be added, it has to be a negative zero error. So zero error is negative. What is the value? Since 45th division is coinciding, what does it show? That 0 has crossed the reference line by 5 division. So it is 50 minus 45 into least count. That will be equal to 5 into least count. Least count is 0.01. So this is 0.05 mm. This is calculation of zero error. Now we have to write the readings. Main scale reading is given here. This is 0.5 mm, 0.5 mm. Vernier scale reading is 25th division is coinciding. So 25 into least count. This will be 0.25. If you add these two values, this will come out as 0.75. And after zero correction, this is to be added. Do remember, if zero error is negative, it should be added. So 0.75 plus 0.05. If you add these two values, that will come as 0. This comes question number 9. A vernier calipers has 1 mm marks on the main scale. So 1 main scale division is given there. A vernier caliper has 1 mm marks. So 1 MSD is equal to 1 MSD is provided, that is equal to 1 mm. It has 20 equal divisions on the vernier scale which match with 16 main scale divisions. Okay, so let us write 20 VSD is equal to 16 MSD. So 1 VSD would be 16 upon 20 MSD. Now what is value of least count? That is equal to 1 MSD minus 1 VSD. If you substitute the value, this will be 1 minus 16 by 20, which is 4 by 20 MSD. Now value of 1 MSD is given there, which is 1 millimeter. So substitute the value here, 4 by 20 into 1 mm. This will come out as 1 by 5 mm. What is 1 by 5 mm? This is 0.2 mm. So option number 4 is correct. Next is question number 10. The density of a solid ball is to be determined in an experiment. The diameter of the ball is measured with a screw gauge whose pitch is 0.5 mm. First let us write the value of pitch, that is equal to 0.5 mm. And there are 50 divisions on circular scale. So value of n is also provided, which is equal to 50. Let us calculate value of least count, that will be equal to pitch upon number of division on circular scale, which is 50, and the values are given in mm, so it will come out as 0.01 mm. The value of least count we have determined. Now come to the reading. The reading on main scale is 2.5 mm. Okay, write main scale reading, which is 2.5 mm. Then come to vernier scale reading. It is showing 20th division. So 20 into least count will give the vernier scale reading. If you multiply this with least count, that will come out as 0.2 mm. Add these two values to get the total. That will come as 2.7 mm. Is there any zero error given? No, there is no zero error given. Now it is saying if measured mass of ball has a relative error of 2%, the relative error in density will be. If we write the formula for error, relative error in density, so delta rho by rho would be delta m by m plus delta v by v. Now since it is a solid sphere, so volume can be written as 4 by 3 pi r cube, and this will come out as delta m by m plus 3 times delta r by r. Now substitute all the values. Delta m by m is provided 2%, so this is 2% plus 3 times delta r. Now what is delta r? It is the least count of the instrument provided, which is 0.01 upon r. The calculated value of r is 2.7. This value will be delta r by r, but since we have to write in percentage error, so it has to be multiplied with 100 to give the value in percentage. I am writing directly the value for percentage error. So this will give you 2% plus, on calculation it will come out as 1.1%, which is 3.1%. Which option is correct? Option number 3. Now the last question is question number 11. Here on the screen you can see two vernier calipers are given there, and for both 1 centimeter is divided into 10 equal divisions on main scale. So 1 MSD is same for both. If you write 1 MSD, that is equal to 1 by 10 centimeter or 0.1 centimeter. The vernier scale of caliper C1 has 10 equal division that correspond to 9 main scale division. Okay, so least count for C1 I am writing, that would be equal to 10 VSD coinciding with 9 MSD. Therefore 1 VSD would coincide with 9 by 10 MSD, and least count we can write as 1 minus 9 by 10, that is 1 by 10 MSD, and 1 MSD is equal to 0.1 centimeter, so it is equal to 0.01 centimeter. The same value you would get for C2 also, but the only difference is that for C2 least count comes out to be negative, which is not correct. So C2 is not a correct vernier caliper, its scaling is incorrect. This is incorrect vernier caliper. Now it is asking for reading of two calipers as shown here are. Okay, So first write main scale reading. What is main scale reading for C1? As you can see, 0 is coming after 2.8. So main scale reading would be 2.8. Now vernier scale reading, which division is exactly coinciding with any main scale division? On C1 you can see this value is the 7th one, which is exactly coinciding. So 7 into least count. This value will come out as 0.07. On adding these two, total value you would get as 2.87. So 2.87 is the reading with scale C1. Now come to scale C2. Here least count is negative, so we cannot apply directly here the formula. If you write main scale reading, in this scale also main scale reading, as you can see, it is the same, which is equal to 2.8. But for vernier scale reading, now you have to make some correction because this is an incorrect vernier caliper. So for vernier scale reading, total 10 divisions are there on vernier scale, in which division is exactly coinciding, that is the 7th. So 7 has to be subtracted from the total divisions on vernier scale. This comes out as 3 into least count. The value would be 0.03. If you add these two values, the result will come out as 2.83 centimeter. Now check out the options, which option is correct. This is option number 3. This question is very important because in this a caliper is provided here which is having incorrect calibration. So how would you, if you get least scale as, if you get least count as negative, how would you take the readings? It would be, for vernier scale reading, you have to write total number of division on vernier scale minus the division which is exactly coinciding. Whereas in case of correct scale, directly we can write the vernier scale division which is coinciding with main scale division. Here you have to subtract this value from the total number of division. So this correction you have to make while taking reading from an incorrect vernier caliper. Is this okay? You all got understood? Okay. Let us solve one question more. A physical quantity x is given by the relation is given here, x is equal to 2k cube L square upon m root n. The percentage error in the measurements of k, L, m and n are 1%, 2%, 3% and 4% respectively. The value of x is uncertain by, here a very interesting word has been used, that is uncertain. It is used to calculate the error that has occurred in x if error in k, L, m and n are given here. So let us start solving this. First, consider the expression of x which is equal to 2k cube L square upon m root n. Now we have to calculate percentage error in x. So from the formula it will be delta x by x into 100 is to be equal to 2 is a numeric constant that is not to be included while calculating percentage error. The next term will be 3 delta k by k plus 2 delta L by L plus delta m by m plus 1 by 2 times delta n by n. As you must be knowing that even the term is in denominator, always percentage or relative errors are to be added and this whole to be multiplied with 100. Now let us substitute all the values. Errors are given in percentage, so it will be 3% plus 2 into 2, that is 4%, plus 3% plus half of 4%, that is 2%. And so the result will be equal to 12%. That is our correct option B. Here to calculate percentage error, we have used the standard formula. But do remember, even if you are not able to use the standard formula, always you can differentiate the given expression to calculate relative or percentage error. So differentiation of expression is the general method to calculate error, but for some standard variation we can use standard formula we have also. You all got understood? Okay, so now best of luck for your preparation, and please do revise a lot number of questions based on this topic.